Hi, Zach. Welcome to lesson number 41. This one's going to be great. I think you're really going to like it. It goes over two different things. It goes over addition of like terms in rational expressions. So you remember that ration kind of means ratio, like fractions. So you're going to have to add like terms, but there's another trick. It's taking it to the next level. The like terms are a little bit hidden. So you wouldn't recognize them right up front if you see it the way that it's written, but if you change all the exponents so they're positive or all of them so that they're negative, you'll be able to see those like terms. So it's a two-step problem, and then you're basically literally going to go over two-step problems, which are a little bit easier in the next section of this. So I think you're really going to enjoy this lesson. I'm going to let you jump right in, and I'll see you when you're done. Bye.
Alrighty, hi Zach. We are going to start lesson 41 today, which starts on page 165 in your book if you want to follow along. So you remember this part when they're listening to the announcements and Bart is like, cool, I broke his brain. Well, we're going to see if I break your brain today because today's lesson is a little tricky. It goes over addition of like terms in rational expressions. Remember, rational, the word ratio means a fraction basically because it's another way to express a ratio. So it's going to be adding like terms in equations where there are fractions in the equations and two-step problems. So these are going to definitely take what you're learning and put it to the next level. So let's just jump right in, okay? So the first part of the lesson goes over addition of like terms in rational expressions. So, I put this here because like terms made me think of, are these alike? Bart and his, doppelganger or whatever who looks exactly like him. I'm going to actually just delete this so it doesn't distract us too much. So basically what it says in the book is, you know how what you've been doing is you have an expression, something like this, and when there are like terms, you can simplify it or you can combine them, right? And there are actually like terms in this expression. You just can't tell because they don't look alike. It's kind of like Bart and that doppelganger. They are alike maybe, but they don't exactly look like they're alike. It's hard to tell. So what we're going to do first is rewrite this expression so that all of the exponents are positive. So that's going to be step one, is to rewrite it so that all of the exponents are positive. Because as we look, here's a -2 on the top, y to the -2 here. And so we're just going to change the way we write this. All right, so let's take it one expression at a time. And we're going to start with this one over here. So if we rewrite this just so that all of the exponents are positive, I'm going to have bx on the top, and then I'm going to divide it by, instead of this x cubed y to the -2, because of this exponent, I'm going to put the y on top and change the sign of the exponent, okay? And then the only thing I have left is that x cubed on the bottom. But there is something else that I can simplify because I have this x on top and this x cubed on the bottom. So I can cancel out one of those x's and just remove this and make this a 2. Okay, so now I have by squared over x squared. Okay, so that's the first expression. Now I'm going to deal with that second expression. So I'm going to look at this one right here. And I see that it's 3by2 on top, but this can be moved to the denominator if I just, divide it by x and put a +2 instead of that 2. So that's how I'm going to simplify that one. I'm going to put 3by squared on top and then this x squared on the bottom. Okay, what about this last expression? We have 4y squared on top and bx squared on the bottom. And because all of the exponents are already positive, I'm not going to do anything to this equation or to that expression. So it's going to stay 4y squared on top, and it's going to be bx squared on the bottom. Okay, so that's what we're left with. And now you can see that there are actually a couple like terms here, right? Because this has the same the same denominator as this one. There's x squared and x squared on both of those. So when we have x squared on the denominator on both of them, basically what we can do is we can combine them. and we'll just combine the top, by squared minus 3by squared, and leave that on the top. And then we're going to put this on the bottom. I know it's getting kind of complicated, but if you're not following along, just let me know. Write that in your homework. Say I don't get it, and I can explain it to you when I get home. But basically, let's just only deal with this for a little bit. And if we only deal with that part of it, what we have on the top is by squared minus 3by squared. And then on the bottom, because those are like terms, you can just have one of those x squared. Okay, does that make sense? The other thing that is interesting about this is that this by squared and this by squared are the same. So it's kind of like the exact same variables, but you have a different coefficient. The coefficient here is 3, and the coefficient here, since there's not one there, is basically 1. So it's kind of like 1x minus 3x. It's just written a little bit more complicated of a way. So if you have 1x minus 3x, the answer is going to be negative 2x, right? So if we simplify this further, it's going to be kind of like 1x minus 2x is going to be negative 2, but instead of x, it's by squared. And the bottom is still going to be x squared. Okay, so now this thing can replace all of this. So hopefully that makes sense, okay? So if I do some cutting, now let's just delete that, I guess. Let's delete that. How do I delete that? Delete. Okay. Now I'm going to take this, I'm going to move it over because this expression replaces all of this, right? Then I need to add this back in. So I'm going to put plus 4y squared over bx squared, and I didn't do anything further to that one. Okay. Okay. Now, so this is basically the answer. Now, what they do is they're going to work the problem again, and they're going to write the original terms so that all the exponents are negative. Okay, so we're going to work the whole problem again. I know. Kind of, let's just erase all of this. Let me make the eraser big, ginormous. Okay. So they want us to get lots and lots of practice doing this. So I'm going to erase all of this, and we're going to do this over again. Dook. Okay, let's make the eraser a little bit smaller now. Okay. Alrighty. So hopefully I didn't break your brain. Now we're going to rework the whole problem by writing the original term so that all exponents are negative. So, you know what? I'm going to start out by simplifying this and just make this an x squared on the bottom because that's just kind of a mess. So let's just make this an x squared from the beginning. Okay, now anything else I can simplify from the beginning? I don't think so. I think that was it. So I'm going to write it again. And even this b, I want you to notice even this b on top, it basically has an exponent that's just not written. But it's a variable, just like x, so it's going to be b to the 1. Same with this b to the 1. Same with this b to the 1 over here. Okay, so the reason that I'm going to do that is because when I make them all negative, you've got to switch the position, right? So I'm going to start with this expression right here. And instead of writing a b on top, I'm going to write a b on the bottom. And it's going to be b to the negative 1. I'm going to move x to the top. And I'm going to leave y on the bottom because it already has a negative exponent. Then I'm going to do minus, and I'm going to do this second part of the equation. And I'm going to leave the 3 on top because that's a coefficient and not a variable, so it's okay to stay on top. But this b comes next, and since it's b to the 1, I'm going to put that on the bottom as b to the negative 1. And then this y squared on top, I'm going to move it to the bottom, y to the minus 2. And then this x to the minus 2, which is already on the top, and it has a negative exponent, I'm going to leave it there. Okay, now I'm going to do this last expression. I'm going to leave the 4 on top because it's kind of a coefficient. See this b to the 1 on the bottom? I'm going to move this to the top and do b to the minus 1. Now I'm going to deal with this y, and it's y squared. I'm going to move it down to the bottom and do y to the minus 2. And then this x squared on the bottom, I'm going to move it to the top and do x to the minus 2 on top. Okay, so this is the expression if we rewrite everything in terms of negative expressions. So I want you to notice one thing, and they want you to notice one thing. You still have like terms, because look at this denominator, b minus 1, y minus 2. It's b minus 1, y minus 2 right here. So you could combine these again, right? And this would be 1x to the minus 2 minus 3x to the minus 2. It would be negative 2x to the minus 2. So you would get the right answer whether or not you did all exponents negative or all exponents positive. They point out that most people feel comfortable with all the exponents being positive. That's probably a less complicated way of doing it. All right, so let's move on to example 41.1. And it basically says simplify by adding the like terms. So first, step 1, I'm going to rewrite everything so that all the exponents are positive. Because, why? Because there might be hidden like terms in there. So we're going to look for the hidden like terms. I'm going to write that down. Look for hidden like terms. And we're going to do that by writing all the exponents as positive. So I'm going to take this part of the expression first. I'm going to leave b, actually, no. First steps first. Let's simplify where we can. So I notice that I have an x here and an x cubed here. I'm going to cancel out one of the x's. How do I do that? The way I kind of think about it is instead of x cubed, I basically have x times x times x, right? And then because I have x times x times x, I can cancel out one of those. Well, I shouldn't do that. I should do it like that. I can cancel out one of those x's with one of these x's. And so I'm left with x squared on the bottom. Okay, now the y, well, let's deal with the b. I'll just write the b. It already has a positive exponent, which is 1, so that's fine. Then I'm going to deal with this y. And the y, I'm going to make it a positive exponent and put it on top. Now I notice I made that line too big, so let's do that. Okay, now I'm going to put minus, and I'm going to deal with this second term. The second term, I have 3by squared. Those are all positive, and I like that, so I'm going to put it on top. 3by squared. Now, this x to the minus 2, it's a negative exponent. I don't like that. I'm putting a positive exponent on the bottom. Okay. I also don't like that I made my line too long again, so I'm going to erase it. There we go. And I'm going to do plus and deal with this final expression here, 4y squared. Okay, so I like the 4y squared. I'm going to leave that on top. Okay. I don't like this b to the minus 1 on the bottom. What the heck is that? So I'm going to put a b on top, but I just noticed something. As I look back over it, these and these, they all are by squared. So I'm going to make mine look the same as those. So I'm going to move this over and put a b. So it's by squared on top. And then I haven't dealt with this x squared, so let's deal with that. And I like the positive exponent, so I'm going to keep that on the bottom. Okay, now what do I notice? I notice that I have like terms because I have by squared over x squared, by squared over x squared, and by squared over x squared. So now I just need to deal with the coefficients, and I can just add all of these together. So over here, basically, we have a coefficient of 1 by squared. So this is just like doing 1x minus 3x plus 4x. What would it be? Well, 1 minus 3 takes you to a negative 2. And then the negative 2 plus 4 is going to take you to a positive 2. So the answer is going to be a positive 2by squared over x squared. And that's going to be my final answer. And let's see if the book got the same thing. And it looks like it did. So final answer right there. Beautiful. Let's do example 41.2. I love it when I get the right answer, at least the answer that's in the book. If I made a mistake, then they also made a mistake. So that makes me feel a little better at least. Here, you might feel like Lisa, I've never gotten a B before. And she's all devastated because she's gotten a B. What a life, huh? Okay, so let's do example 41.2. Simplify by adding like terms. Again, we are going to look for those hidden like terms and do that by making everything in the positivo. So let's try it. Let's deal with this first expression first, a to the minus 3b. Okay, you know what? I already don't like this at all. What's with all the b's? I'm just going to move, well, okay, let's make it all positive. So if I make it all positive, I'm going to move that a to the negative 3 to the bottom and make it a to the 3. Then I'm going to put an exponent of 1 on this b right here so I can bring it to the bottom as, you know what? No, let's just leave it right there because it's already positive. Let's leave it right there. And let's deal with this b to the negative 3 because that's really annoying, and just put b to the 3 on top, and then you've got an extra b up top because of this b that was already there. Now, if you forget the exponent rule, like, you know, change, how do we multiply this and multiply the exponents? And it's actually b to the 4th. But if you forget that, just change that b cubed into b times b times b, into 3b's. And then you notice that you have 4b's all together. So if you have 4b's, then you can just simplify the whole thing into b to the 4th. Oh my heck, I like that so much better. Isn't this so much better than what's up here? I mean, what the crap is that? Okay, so let's move on to the next expression. And the next expression is 2b4 over a3. And you know what? Those are already all positive, so I'm just going to leave it the way it is. And then I notice I've got like terms again. I've got an a cubed on the bottom and an a cubed on the bottom. So can I put those together? Yes, I can. So this also, we have like terms on the top because we have b to the 4th and b to the 4th. So this is the exact same thing as saying 1b4 plus 2b4 is 3b4. Before what? Okay, and then on the bottom, we just have these a cubed and a cubed. So we're not going to change anything there. It's still a cubed. Why is it a cubed and not 2a cubed? Because since it's a denominator and we're adding fractions, it's like getting this equal denominators. When you add fractions, the denominator stays the same. Okay, so don't make that mistake. I want you to remember the denominator stays the same when we add fractions. So it's 3b4 over a cubed. Let's do the next example. This is example 41.3. I clearly have a Simpsons thing going on here. And since I don't want you to go to clown college when you grow up, I want you to go to an actual real college. You got to keep learning this stuff and know it inside and out. All right, so example 41.3 is just like the other ones. We're going to simplify by adding like terms. First thing we're going to do is we're going to make all the exponents positive so we can identify those hidden like terms, okay? So is there anything I can simplify right off the bat? I don't really see anything that I can simplify. So I'm just going to move on and make everything a positive exponent. So first I'm going to deal with this first expression. Okay, so I've got a 7 on the top, which can stay there. I've got a b squared, which can stay there. But I do not like this a to the minus 3. What the heck? Let's put a to the 3 on the bottom. And I don't like this c to the negative 1 down there. I'm going to put a c to the 1 up on the numerator, but it doesn't really need a 1. That's a little bit superfluous. So I'm just going to leave it with just a c. Now, let's move on to expression number 2. 5b squared over a cubed. Oh, I like that so far. So I like the 5b squared over a cubed. I don't need to do anything with that part. But I don't like this c to the minus 1. What the heck? Let's put a c on top. I'm sensing a theme here. I can tell there's going to be like terms. Now, on this third expression right here, I'm dealing with 3b squared over a cubed c. Hey, that's a winner. They're all positive exponents. Let's just write it the way it is. I love that. Okay, now, do we have any like terms? Yes, we do. This one is a like term because of this denominator, and this one is a like term because of this denominator. This one is not. That extra c in the denominator just messes everything up, so that is not a like term, so we're not going to add those. But we can add the first two, and when I say add, I mean add a negative because you've got this minus sign here. So what you're really doing is adding a negative. Now, are these like terms where you can just add them? Yes, they are, because you've got 7b squared c minus 5b squared c. Now, what if there was just like an x or something else there? Then what I would do on top is leave it like this. And then I would keep the a3 on the bottom. So I just want you to know that you can still add them, but you would just leave them like that. But that's not the problem we're doing. There's no x there. So because there's no x there, it's just like adding 7x minus 5x, and it would be 2x. But instead of 2x, it's 2b squared c. On the bottom, it stays the same, a cubed. And then we're going to add just this last term right here exactly the way it is. I'm not going to change it at all. And that is going to be the final answer right there. All right, we're going to move on to figuring out how to do two-step problems. This is not the two-step like the dance. This is two-step problems. Okay, yeah, I know, I've got problems. All right, so we're going to do two-step problems. I know you're going to concentrate really super hard, just like Lenny. Or is that Carl? I can't remember. Tell me if it's Carl or Lenny. Okay, so we're going to do example 41.4. And the question says, if x plus 3 is 7, what is the value of x minus 8? So the first thing that we're going to do is we're going to figure out what x is based on this. And then whatever x is based on that, we're going to plug that into this equation. Okay, so step 1 is to just say, well, if x plus 3 equals 7, then what is x? So to figure that out, we subtract 3 from both sides. I know you can do this in your head, but still, this cancels out. X is equal to 7 minus 3, which is 4. So the answer is x equals 4. Now, we're going to take this number and we're going to plug it right into this equation. Okay, so we have 4 minus 8. Instead of x minus 8, it's 4 minus 8. And so 4 minus 8 is equal to negative 4. So if x plus 3 is 7, that means that x is 4. And the value of x minus 8 is going to be negative 4. All right, let's do example 41.5. I know you're probably feeling a little like this right now. Hang in there. We are almost done. This is actually the last example. And then you get to move on to your homework and be done with this stuff for the day, okay? So enjoy this easy stuff, okay? Because I think you're going to get this. If x minus 5 is 7, what is the value of x plus 4? It's a two-step problem. You got to do first things first. Don't take shortcuts. Show me your work. Please show me your work. Because if you get these wrong, I don't know why you're getting them wrong if you just write x is 10 or whatever. So please show me your work. So let's start with the beginning of this two-step problem and find the value of x. So to do that, I'm going to add 5 to both sides. X is equal to 7 plus 5, which is 12 Reno. Okay, now we use that 12 to plug it in right here. And we have, instead of x plus 4, the value of that is going to be 12 plus 4, which is equal to 16. Okay? Alrighty. Whatever. I know you know this. So I'm going to have you go ahead and do the rest of your homework right now. I can't wait to see what you do with it. Have a great day, Zach. Bye.